Hey guys, welcome back to my YouTube channel. In this video, looking at percentage errors. Like, what are percentage errors? So, percentage errors are measurements. Like, you measure something, measurement compared to a true value. That is, you have like the actual measurement of a thing, then compare it to the actual value in percentage format, like percentage error. So it has been percentage errors. So some people will be like, why can't you just do errors like subtract? What's the error in this? Maybe you made an error. Maybe you're meant to measure something of 10.2, but it's actually 10. So the error is like 0.2. Let's say this one is centimeter. So you can just say okay, 0.2 is there an error. But in a situation whereby you have maybe the error was like is like 0.15 centimeter. So compared to sorry, let's say 7, okay, let's say this is 95. So compared to this is very large. Like the error you made it is very, very large compared to this. So that's why percentage error is very necessary. Or in an instance whereby you have an error of 5, let's say 5 centimeter. If you are comparing to like okay, something that is actually like maybe say 95. Okay, so that's error. But the error is very large, but if it was something like as let's say 10 meters length, is the error is minimal. It's just something you can just say, can just leave it. Something like that is not really important. But compared to 95, it's actually a big issue. So that's why error percentage error is necessary to look into. So what's percentage error? Uh just you comparing the what you measured, like the error or what actually measured compared to the true value. And uh what was the formula of percentage? Percentage error can be found by percentage error equals to error. We define error later over the true value or the true value or the correct one. Then why you tell me to be whatever you tell it to be. Yeah. So whatever I tell it to be is a percentage error times 100. So it's just percentage. So error basically is the absolute of the measured value, or let's say results. This is like results, or maybe you calculated something minus the true value. So take note absolute, absolute. I'll be showing an example what you mean absolute. Absolute means whether you get an R, a plus or negative, the answer has to be a positive. So a negative or a positive answer have to be positive answer. So we'll be looking at this example. So say a metal rod was measured as 9.2 meter. If the length is 9.43 meter, calculate the percentage error. So we have to take note of the parameters. So firstly, we're given that means the measured. See the first one measured is 9.2 meters. Then the real that's the true value now. True value is 9.43. Right. So sorry, the units are necessary as well. So one of the things why we want to use this formula this formula to calculate it, we need to calculate our error. So our error here in this instance will be error equals to 9.43 minus 9.2. If you notice I kept the true value for uh it still give us the same thing. Or CG 99.2 minus 9.43. The main thing is it has to be an absolute answer, that is, it has to be a positive answer. And now, answer here in this regard is 0.23 meters. So we use the formula here. Percentage error is equals to 0.23 over what's our true value here? That's the main thing. You have to identify your true value because that's actually necessary for the formula. So that's like 0.43 times 100. So you put this into your calculator, you'll be having 2.439%. Can just round it up to 4%, depending on the units you are expected or told to round it up to. So we'll be looking at another example in this question in this video. So a student mistakenly approximated 0. This is a little bit technical. A student mistakenly approximated 0.03612 two decimal place instead of two significant figure, which is the percentage error. What is the percentage error? Sorry. So let's look at the second question. So I think what we need to do is instead of the true value is the two significant figure, that's 0.037, right? So and the measured value, okay, so or the let's say the result, yeah, result, like I said here, that was the result Amy got. That was it did it to this map, that was going to be 0.4. Let's use this error formula. Now the error, so that our result minus this, so absolute of 0.4 minus 0.037. So absolute, so that will give us an 0.003. You put that in the calculator. Then the formula, putting it back to our percentage error. Now is 0.003 all over what's our true value. Take notes. Times 100. So that percentage. So our final answer is, if you put this into your calculation, you have something like 0.108. So it's trying to dump out 8.1%. So this is just like an example, one of the examples in percentage error. The other examples such as whereby you will use the different units of of the unit of places of the distance, or even calculated materials. You are asked to find the percentage error. We'll be doing that in a subsequent video. Do it to check it out. Thank you. See you in the next video.